Now let me do this integral by three methods. This one is definitely not an easy one. And this is two. This is two. Let me rewrite it again. Right, better one. This is dx over sine 2x plus 2 sine x. Yeah, it looks better. Now, how do I start? This is method one. Method one is that I take 2 sine x out, 2 sine x. So it left over cosine, right? Cosine. And this is 1. At the same time that I multiply by sine x, both numerator and denominator, sine x. So it becomes sine x squared, isn't it? Yeah. So then this is equal to, now sine x dx is the d cosine x, but negative, right? I leave a negative outside, and I change everything to cosine. I take 2 out, so 1/2 is negative. Cosine, this is 1 minus cosine square x. This becomes cosine square, cosine x plus 1. So now everything is in cosine. So I can replace cosine by a new variable t. T is equal to cosine x. This is equal to 1 over 2 integral and the dt, 1 minus t squared. 1 minus t squared is 1 plus t, 1 minus t, right? And it's 1 plus t. So this is 1 plus t squared times 1 minus t, right? Okay, good. So obviously now we can use by partial fractions. Negative 1/2. You know by partial fractions, right? Now let me omit some details. And this is a repeated linear. So it becomes like 1 plus t squared, 1 plus t, and 1 minus t. Right? 3 fractions, and then we determine the coefficients. Now let me save time, and I know you have to fill up the details. This is equal to 1/2. This is equal to 1/4. This is equal to 1/4. And the plus and plus. All right. Excuse me for omit the detail of those determining of fractions, coefficients. Then this one is equal to well, this becomes negative dt over this is not jump, okay, negative 1/4 dt 1 plus t squared. And this minus 1/8 log 1 plus t, right? And this becomes negative, therefore become plus 1/8 log 1 minus t. Absolute value. And plus c. Then we all know this one. This one is well, this becomes a positive 1/8, right? Positive 1/8 over 1 over 1 plus t. And these two, positive plus 1/8 log 1 minus t, 1 plus t, plus c. Okay, then we fill up a t by cosine x. So this will be this is 4, right? So where is it? 4, 8 come? No, this is a 4, sorry. Excuse me. 4, therefore this is 1 over 4, 1 plus cosine x. That is this term. Plus 1/8 log 1 plus cosine x, 1 plus cosine x. See, okay, that is the end of integral by method 1. Okay, method 2. Now let me write this time carefully. Okay, this is sine 2x. Put on light. A plus 2 sine x and then dx. Okay, that's the question. Now, method 2, I multiply numerator and denominator both by 1 plus cosine x. No, 1 minus cosine x. To both denominator and numerators. And this becomes integral 1 minus cosine x dx. Now I take 2 sine x out, right? It becomes cosine x plus 1 multiplied by 1 minus cosine x. Sorry, it's always something. Okay, then becomes integral. Now the denominator 1 minus x, 1 minus cosine, 1 plus cosine becomes 1 minus cosine squared. That will become sine squared, right? So it becomes sine cube. Let me take 2 out. Okay. So that is the denominator. And the numerator is 1 minus cosine x dx. So I split the integral into two, right? The first one is 1/2 1 over sine is cosecant. So cosecant cube x dx. And the second one, minus 1/2 integral sine cube x. Now x dx is d sine x. So that this integral can be done easily. This one, well, and graph paper. Well, do you know this basic integral, or rather, cosecant cube x dx. I consider this basic because you should have practiced the method by parts, you know. This is a negative, it's a 1/2 negative half cosecant x and cotangent x minus integral cosecant x. All right, I just consider this as a basic formula. This is a negative 1/2 cosecant x cotangent x plus 1/2. That is, this is also basic. 1 cube is equal to, okay, good. This is a log cosecant x minus cotangent x. All right, I consider these are basic integration. Therefore, you should know them, or you should have practiced before. All right, so this one I'm not spend time for doing it. Rather, I use the result. Okay, so this becomes a minus 1/4 cosecant x cotangent x and plus 1/4 log cosecant x minus cotangent x, and plus this, which is equal to, this integral is rather easy, equal to, is equal to 1/2 negative, negative 1/2, so it becomes 1/4 sine square x, okay, yeah, plus c. So this integral is this. Yeah, negative become plus, this is negative, okay, negative half times this one is quarter. So this result becomes negative 1/4. Let me rewrite again. This is a cosecant x cotangent x plus 1/4 log cosecant x minus cotangent x plus 1 over 4 sine square x. And this one is equal to negative 1. This is a 1 over sine. This is cosine over sine. So there's a sine square and cosine, right? Plus 1/4 natural log natural log cosecant minus cotangent x minus a plus 1 over 4 sine square x. Now this one and that one I can combine, right? So this is 4 sine square x and 1 minus cosine x and plus 1/4 natural log cosecant x minus cotangent x and plus c. Omit c there, okay. Omit plus c. That is a end of result by method. My method. Method 2, right? Yeah, this is method 1, yeah. The result has some difference, but doesn't matter. See, you can verify by do some further work, you know. But I'll leave the work to you. What I mean that these results will be the same, you know. You're just doing some algebraic work. You will verify they are the same. Now let me do this one by small. Third method. The pen is sometimes the ink is leaking, so dx. You know, when I choose the pen, see, I don't want that the color is fainted. Rather, heavy color shows better. But sometimes the pen is the heavy leaking. The heavy colors ink leaking easily. Okay. Anyhow, this is 2 sine x. See, this pen is not really good. Okay, now let me do with this third method. I take 2 sine x out. So left is cosine x plus 1 under dx. Well, then I use this is 2. Now sine x is equal to 2 sine half x cosine half x, right? Cosine x plus 1 is equal to 2 cosine square half x. And under dx. But I hope everything is okay. Now this becomes 1 over 8. Okay, then this becomes a sine half x cosine q half x dx. And the numerator is 1. 1 is equal to sine square half x plus cosine square half x. You see, this is what I meant. The ink is leaking, you see. But anyhow, this allows me to simplify the rational functions into 2, right? This one over this one becomes integral sine half of x over cosine cube half of x and dx. And the second one becomes 1/8, right? This is a sine half x and cosine half of x dx. Yeah. This one is a tangent, right? Tangent half of x. And remaining 1 over cosine square is secant square of x. Right? Dx, I can write d half x multiplied by 2. And this becomes sine x, I'll change it to 4, right? Yeah, this is sine x. Well, 2 sine half x cosine half x becomes 2 sine x becomes sine x. So that's why the 2 cancel with this one. Becomes the 1/4. And this one, it becomes 1/2 tangent square half x, right? Well, times 2. So it's been out still 1/8. This is a cosecant, right? Cosecant x dx. As I said before, this we consider as a basic integral. You can do easily. This is a 1/8 this now how do we simplify this one? Now I can leave it for a while. This one is equal to this is 1/8 log, right? Cosecant x minus cotangent x plus c, okay? Now this one, 2 over 2 is 1. I can use secant square half x minus 1. Okay, that was easier to simplify the result. So this is equal to 1/8 1 over secant is cosine square, right? Yeah. Minus 8. Minus 8 is combined with the c, right? We can omit that constant. So cosecant x minus cotangent x plus c, okay? Yeah, this one is equal to This one is equal to 1/8. It's 1 minus sine square. I try to simplify that one. This half x, right? So this is half x, I'm sorry. This is 1/8 cosine half x. Cosine half x is equal to 1/2 cosine square plus 1, isn't it? Yeah, plus 1/4 log, I forget log cosecant x minus cotangent x plus c. And this becomes a 1/4 cosine x plus 1 plus 1/4 log cosecant x minus cotangent x plus c. You know, I get another result by method 3. These methods, you know, well, I lost the papers. These are 3 results. Might be some difference, but you can easily, well, maybe not easily, you can verify that they are the same. Okay. Well, like this one, if I don't use this, then it may show different answers. But I use this, you know, it shows this answer, which is the same thing as my method 1 or method 2. Okay, thank you.